This sign is a perfect example of a slope triangle. The rise is 5 and the run is 100. Slope is equal to rise over run. So the slope of a road with a 5% grade is equal to 5 over 100, which reduces to 1 over 20. Therefore, though it's not drawn to scale, the slope of the line representing this road is equal to 1 over 20. But you don't always need to use a slope triangle and find the ratio of rise to run to find the slope. Come on, let's hit the ski slopes and I'll show you another way to find the slope of a line. What's the slope of this line? We've already seen how to find the slope of a line using a slope triangle. We pick 2 points on the line, draw in a slope triangle, find the rise and the run, and compute the ratio of rise to run to find the slope. But we can look at this whole process in a different way. If you know the coordinates of 2 points on the line, you can find the rise, the vertical change, and the run, the horizontal change, without counting squares. For example, to find the vertical change, or rise, between the 2 points, you can find the difference between their y coordinates. Let me show you. We've got the coordinates of 2 points on the line. The y-coordinate of this point is 3, and the y-coordinate of the other point is 4. Subtracting the y-coordinates will give us the vertical change from one point to the other. 3 minus 4 is -1. So -1 is the vertical change, or the rise, between the 2 points. Likewise, to find the horizontal change, or run, between the 2 points, we just find the difference between their x-coordinates. So let's look back to the points. The x-coordinate of this point is 5, and the x-coordinate of the other point is 2. Subtracting the x-coordinates will give us the horizontal change from one point to the other. 5 minus 2 is 3. So 3 is the horizontal change, or run, between the 2 points. Since rise over run is the slope of the line, this method also tells us that the slope of this line is -1 over 3, or -1/3. Subtracting coordinates provides us with another way to find the slope of a line. To use this method, all you need to determine the slope of a non-vertical line is the coordinates of 2 points on that line. These coordinates are used in a formula to find the slope. Now, before I show you the formula for the slope of a line, I want to explain a few pieces of algebraic notation that are commonly used in finding the slope. In algebra, to represent the coordinates of 2 different points, we use this notation. The sunken numbers following the x's and y's are called subscripts, and the notation is read x sub 1, comma y sub 1, and x sub 2, comma y sub 2. The subscripts are used to help distinguish between different pairs of coordinates. Since we need to deal with several points at once, it's important to know which point you are talking about. Typically, the first point is called x sub 1, comma y sub 1, and the second point is called x sub 2, comma y sub 2. Take a look at how this notation is used in the formula for slope. The formula for slope says that if you're given the coordinates of 2 points on a line, x sub 1, comma y sub 1, and x sub 2, comma y sub 2, the slope is equal to the difference in the y-coordinates, y sub 2 minus y sub 1, over the difference in the x-coordinates, x sub 2 minus x sub 1, so long as x sub 2 does not equal x sub 1. As we've seen, this formula makes sense. Subtracting the y-coordinates gives us the vertical change, or the rise, and subtracting the x-coordinates gives us the horizontal change, or the run. Subtracting the coordinates gives us another way to find the rise and run from one point to another. Before we move on, let's take a closer look at this formula. Notice that in both the numerator and the denominator of the formula, the coordinates from point 1 are subtracted from the coordinates from point 2. This is the trick to using the formula for slope. You must be very careful to use both coordinates from one of the points as the first number in the subtraction problem, both in the numerator and in the denominator. Likewise, you must use both coordinates from the other point as the number that's subtracted in both the numerator and the denominator. To keep things straight, it's often useful to call one of your points point 1 and the other point point 2. It doesn't matter which is which, so long as you can keep them straight. So let's do the same problem one more time. But this time, pay close attention to the order that things are subtracted. Again, here's the line. On this line, we found the points 2, 4 and 5, 3. If we call this point 1 and this point 2, we call the coordinates of point 1 x sub 1, y sub 1, and the coordinates of point 2 x sub 2, y sub 2. The formula tells us that slope is equal to the change in y sub 2 minus y sub 1, over the change in x sub 2 minus x sub 1. Y sub 2 minus y sub 1 is 3 minus 4, and x sub 2 minus x sub 1 is 5 minus 2. Notice how the coordinates from point 2 appear first, and the coordinates from point 1 appear second in both subtraction problems, the one in the numerator and the one in the denominator. Keeping this straight is the key to the slope formula. Once the problem is set up, the rest is simple. All you have to do is subtract to find the slope. In the numerator, 3 minus 4 is negative 1. And in the denominator, 5 minus 2 is 3. That makes the slope equal to negative 1 over 3, or negative 1/3. That means if you start at any point on the line and make a vertical change of negative 1, followed by a horizontal change of 3, you'll end up at another point on the line. Since all parts of the line have the same slope, the slope, negative 1/3, describes the steepness of the line. I'm definitely enjoying the slope out here. Let me go up and ski another line, and we'll use the formula to find the slope. I'll see you at the top. So, what's the slope of this line? This time, since we have no grid lines that we can use to count the rise and the run, we'll have to use the formula for slope. To use the formula, we'll have to pick one of the points as point 1 and the other as point 2. If we call this point point 1 and this point point 2, y sub 2 minus y sub 1 will equal 1 minus 2. And x sub 2 minus x sub 1 will equal 4 minus 2. Simplifying in the numerator, 1 minus 2 is negative 1. And in the denominator, 4 minus 2 is 2. That makes the slope equal to negative 1 over 2, or negative 1/2. So, if you start at any point on the line and make a vertical change of negative 1, followed by a horizontal change of 2, you'll end up at another point on the line. Since all parts of the line have the same slope, the slope, negative 1/2, describes the steepness of the line.
Yeah!